Let's take a look at what happens when we combine resistors both in series and in parallel in one circuit. When we do that, we need to start from the inside and work our way out and find equivalent resistances. When we do this, we want to start with the innermost collection of resistors, find the equivalent resistance of that, and redraw the circuit to show that equivalent resistance either in series or in parallel with the next set of resistors further out. Eventually, we want to get to the equivalent resistance of the entire circuit that will allow us to find the current flowing through the circuit. Let's take a look at an example of this and walk through how to do it. First thing we should do is draw the circuit. So we have a 10 ohm resistor in series with two 30 ohm resistors, and those resistors are in parallel, and then we hooked it up to a power supply. Household circuit means 120 volts. So we'll start with our power supply, go to our first resistor, that's 10 ohms, and then it's in series with a pair of resistors that are in parallel, and then this goes back to the power supply. The innermost part of the circuit here is my parallel set of 30 ohm resistors. So I'm going to start there and find the equivalent resistance of this part of my circuit first. To find the equivalent resistance of resistors in parallel, it's 1 over the equivalent resistance. So 1 over 30 plus 1 over 30 is 2 over 30. To find the equivalent resistance of that, I take the inverse. So equivalent resistance is 30 over 2, or 15 ohms. Now I can redraw my circuit with my same power supply, my 10 ohm resistor, and now a 15 ohm resistor, and I find the equivalent resistance of that. When they're in series, remember I just add them, so the equivalent resistance of this portion is just 10 plus 15, or 25 ohms. Since my voltage is 120 volts, I can find the total current in the circuit by using Ohm's law. So 120 volts equals my current times the equivalent resistance of 25 ohms. So my total current equals 4.8 amps. Flowing through the 10 ohm resistor is 4.8 amps. So the voltage of my 10 ohm resistor is 4.8 amps times the resistance of 10 ohms. So I get 48 volts. The voltage across each 30 ohm resistor is the same. Remember, voltage is the same for each resistor in a parallel arrangement. And the voltage across the 30 ohm resistors is equal to the total voltage minus the voltage across the 10 ohm resistor. So we have 120 volts minus 48 volts. So we get 72 volts across our 30 ohm resistors. Because each of the resistors is the same, the current splits equally as it goes down each branch. So I of each 30 ohm resistor is half of my 4.8 amps. So the current through each of the 30 ohm resistors is 2.4 amps. So now I have the current for each resistor, 4.8 amps in the 10 ohm resistor, 2.4 amps in the 30 ohm resistors. I have the voltage across each resistor. Voltage across the 10 ohm resistors, 48 volts. Voltage across the 30 ohm resistors are each 72 volts, and I have completed this problem. If we take a look at a second example, we're looking again for voltage and resistance for each resistor. We have that same 10 ohm resistor, and it's in series now with our 30 and 6 ohm resistors. These are in parallel. And household circuit, same thing. So we have 120 volts going again to our 10 ohm resistor. In parallel, now we have two different resistors. One is 30 ohms, one is 6 ohms. We're going to do the same process. We're going to start out with the two resistors in parallel and find their equivalent resistance. So that will be 1 over 30 plus 1 over 6. If we do it in our head, it's 1 over 30 plus 5 over 30. So our equivalent resistance is 30 over 6, or 5 ohms. So we put that now in series with our 10 ohm resistor, so we redraw the circuit. 10 ohms now in series with 5 ohms. And there's our new circuit. Equivalent resistance here is just going to be 10 plus 5, or 15. So our total current is going to be the total voltage divided by the equivalent resistance. So our total current this time is 8 amps. So the current going through my 10 ohm resistor is 8 amps. The voltage across my 10 ohm resistor is that 8 amp current times the resistance, or 80 volts. The voltage across my parallel resistors, so we'll call it voltage parallel, is going to be, again, my 120 volts minus 80 volts. So I have 40 volts across those resistors. So the voltage of my 30 ohm resistor is 40 volts. The current through my 30 ohm resistor is going to be that voltage divided by its resistance. So 40 volts divided by 30 ohms. So I get 1.33 amps. The voltage across my 6 ohm resistor is that same 40 volts. The current through my 6 ohm resistor is that 40 volts divided by the resistance, 6 ohms. So I get 6.67 amps. So same process. Again, I start with the innermost arrangement of resistors, find the equivalent resistance for them, and keep working my way out.